When a user interacts with the computer to put input things or to get output, you have to have some kind of interface to react with it. And of course, that interface for a computer is a keyboard. And so when you push buttons on a keyboard, the computer tries to interpret what you're wanting with that particular button. Now, we already talked about that computers work in a machine code, which is just all binary. It's all binary numbers. So when you press the key that has a T on it, what does that mean to the computer? Well, the computer, it means nothing. It means a binary type of a number. But you don't want to, most people don't understand binary, and you don't want to have to type in binary to get a capital T, for instance, in a Word document. So when you press any key on the keyboard, there is a code, a conversion code, that the computer uses. And in America, we have what we call Ascii codes, or the American Standard Code for Information Interchange. And basically, every key character, key input, is associated with a decimal number, which, of course, is used as a binary number for a computer. And we're going to look at these Ascii codes and kind of see kind of what's working on the background of the computer. Normally, no one has to understand this. You don't have to know that when you press a certain key on the keyboard what the binary code exchange is for that. But this is a computer science class, so you have to know it. Keep in mind the ASCII interchange is just a subset of a much bigger interchange called the UTF-8, or the Unicode Transformation Format. We have a lot of other keys, or keys that are used in other foreign languages and things that would have to also have an exchange code for them. So ASCII, which is what we're going to look at today, is just a subset of a bigger thing. Okay, so if you just Google on there ASCII conversion chart or something online, you should go do that and see the different interchanges, the ASCII code charts. And this one here has the ASCII 2 number, the ASCII 2 code, which is all just a decimal number to make it easy for us. So so I'll just kind of quiz you. What is ASCII code 60? If I use a decimal number 60, what symbol, what input symbol on a keyboard is that? Well, if you look under ASCII 2 and you look under 60, you'll see it's the less than symbol. So if you click the less than symbol, that's using ASCII code 60, which would be represented in the computer as the binary number 460. So when you push that, the computer gets the binary number 460, and it knows how to output that symbol back out depending on that particular binary code. You'll notice here that the hexadecimal code is actually given for these. The hexadecimal code for 60 is 3C. So that's given also. A lot of the charts will give you a lot of different numbering systems. So you might have the hex code, you might have the octal code, and you might actually even have the binary code on there also, except for binary codes are 8 bits long, usually 8 bits long for all these characters. So that's kind of cumbersome for a chart, so a lot of times they'll leave the binary off. But what we're going to do is we're going to actually write these codes in binary. So let's say that I wanted to, we'll go ahead and do the less than symbol. I want to do the less than symbol, and I want to program the computer to output the less than symbol, but I want to do it actually with machine code. I'd have to tell the computer what's the binary code for the less than symbol to print out the less than symbol on the screen, this less than symbol. Well, the decimal code, ASCII code for it is 60. It's the ASCII 60. And so what is that in binary? Well, if you remember, we have our 8 bits. And we have 1, 2, 4, 8, 16, 32, 64, 128. And so I want to put this in the binary code for it. So 128 goes into 60 0 times, 64 goes into 60 0 times, 32 goes in once. And what do I get when I put that in for take it out of 60? Well, I would do some subtraction, 60 minus 32, and I'd get 28. So I have 28 left over. So 16, does that go into that? Yes, it goes in one time. I could subtract 16 from 28, and now I have 12. 8 goes into that, and I'd have 4 left over. 4 goes into that, and then I have nothing left over, so I put zeros in there. So there is the binary code for the less than sign. 0011, 1100. That's what the computer is seeing and doing and using whenever you type the less than symbol in. Let's try to write a word. Let's say, let's do it. Let's write hi! Exclamation point. So there's 3 key codes, 3 key inputs that you'd have to do to type that into a word processor. You'd have to do a Shift H, a capital H, and then the I key, and then the exclamation point. And what would this be in binary? What is the computer using in binary here? Well, the capital H is what? Where's the capital H? Because there's difference between the capital letters and the lowercase letters. If you notice down here, we have capital letters starting right here with an A being Ascii Code 65, and a lowercase a is Ascii Code 97. So I'm going to write down the Ascii codes here for these. 65, or H, capital H is a 65. And a lowercase I is a 105, a 105, and an exclamation point. Oh, I should have looked at this earlier. Where is that? There it is. I think that's it. Exclamation point is 33. By the way, look right above that. You have an Ascii code for a space. You get the space bar, it's Ascii code 32. So the computer still needs a code for it, and it's going to be in binary. It's not going to be in these decimal numbers, but we can convert these to binary. Okay, so 65. So I need 3 things, and that's 3 bytes. And then there's another one. And there's the exclamation point. Okay, so for the capital H, I need 65. So that's going to be 0, 1. Put a 64 out of 65, and all I have left is 1. So I can put zeros in for everything here and a 1. So that is the binary code. That first binary, that byte of information, would be a capital H. That byte of information is a capital H. 105, okay, so I need 0, I need 1. 64 from 105 would be 41. I have 41 left over, so I can put a 32 in for that. That would leave me with 9, so that's a 0. The 8 would be a 1, and that leaves me with 1 left over, so that should be it. I hope I'm doing this correctly. I'm doing this on the fly, so that should be the binary code for the letter I. The exclamation point is a 33. 33, so that's 0. 128 goes into that 0 times. 64 goes in 0 times. 32 goes into it 1 time with 1 left over. So I'd have that. So this looks like a lot, but this is how computers work. This is 3 bytes of information to spell capital H-I exclamation point. To spell that in a Word document, this is the amount of computer code that it would take to do that. So these are ASCII codes, are given decimal numbers assigned for every kind of key input, and the computer's not actually using that decimal number, it's using that decimal number in binary format. Okay, that's probably good enough. I'll just go to this next page here, and you can pause it on this page and I'm not going to actually tell you the answer. You'll know if you got the answer, I think. Let's here's a binary code. Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes of information. And what is the code? What does that binary code tell the computer maybe to print in a Word document? So I'll just you should just pause it there and try to decipher that.